Hey everybody, Phil Kerner here, the Tool and Die Guy, and we're going to continue on tonight with Angles Made Easy Part 10. Last week was the intro to ball dimensions, and if you recall, we used our handy dandy chart that you were able to download and figure out a ball dimension across here. And a few of you guys did point out I did make a mistake on that video when I was all done. I took the dimension, we were using the 10 degrees down to the half-inch ball, 5479, and at the end of it I told you to add a 1/4 inch for the other half of the ball. I forgot this chart already does that, and you're going to see why I made that mistake. I did put annotations on the video and updated it that shows that the correct dimension that we're looking for is 1.371.5. So I'm going to show you tonight how to do this from scratch, because you're going to need to know this, because as I said last week, this chart works great as long as the angle that you need to know is on my chart, okay? But if it's not, you need to know how to do this. So I thought it'd be much more practical tonight to do this, the same problem we did last week, and show you how that number comes out. And it'll be fun because I'm going to do this live, and sometimes weird things happen when you do it live, okay? So to recap, I called this block 1 inch thick, and then what we needed to do, we needed to know this dimension first, and that was one of the first things we learned, the drop in an angle. 10 degrees in an inch, and that is 10 tangent, and times 1, same thing, right? 0.1763, and we're going to take that from the 1 inch, plus or minus, let's see, 176.3, 1 inch minus 0.1763, 8237. Got to know that number, because to get the ball dimension we're going to add that number plus the ball dimension, and then we'll have the whole thing. Now here's what we didn't cover last week. Very simple, and again I love these videos because we can do this as often as you can watch this as often as you want. To do a ball dimension, what you do is you need a 90-degree angle from here to here, perpendicular to that 10 degrees. So that's that. Then of course this just goes straight across. That's that. And then you split that. And you'll see this in a second. Dissect it just like I'm doing. You can hand sketch it or do it as nice as I'm doing. Okay, what we learned and we talked about always is to find the triangle. Well, here's the triangle you need to solve right here. There it is. We know, now remember I showed you too, sometimes it's worth your time to draw the triangle out separately. And believe me, it seems redundant to do this, but it gives you a little room to work. We know this side is, if this is a half-inch ball, that means half of it, which is the radius, would be 0.250. We need to know this. Now, what else do we know? Remember I said you need to know two things about a triangle. We know this angle. Do we? Yes, we do. This is a 10-degree angle here, okay? So if we went from here to here, this straight line to this straight line, that's 90 degrees. Just take 10 off of it. So now the distance between here and here is 80 degrees. You're splitting it. So this is 40 and this is 40. So now this angle is 40 degrees. This is a big lesson. This is a true trigonometric fact here. When you do what I just did and split that in half, your angles, I think it's called something like, opposing angles are always equal. Forgive me, I'll look that up. But these, again, that's how we get there. 90 from here to here, minus 10 means from here to here, this surface to this surface is 80. And you just dissect that, and now this angle becomes 40, half of 80. Okay? So now what do we know? We know the angle, and we know what? The side opposite. Because our arrows are touching here, this becomes the adjacent, opposite, and hypotenuse. So we need to solve for the adjacent to solve this problem. So here's my old trig book, same chart you guys already have. So what we're going to do is go through this, and we're looking to solve the adjacent with something we already know. There we go, right there. Opposite times cotangent. Okay? So opposite times cotangent of 40 degrees. And again, I hope you got this calculator, okay? I don't make any money off of selling this calculator. I just want you to have the same one I'm using. So let's take that. Opposite is 0.250. 0.250. Let's start over. Let's take get the cotangent first. So 40 tangent, then we're going to hit the 1 over x button to get the cotangent, times, that inverts it, times 0.25 equals 0.2979. So that triangle's side is 0.2979. So if this is 2979 from here to here, now we just add half the ball, 1/4 inch. So let's add it all up. 0.8237, 0.8237, that's this dimension, plus 0.2979, plus 0.250. 1.3716. That was a tenth off. I might have rounded something off, but got the point here. Okay, 1.3716. And that was the correct answer from last week. If you rewatched the video, I recalculated it. So that is solving for the B dimension on any ball dimension on this chart. Okay, there's as we looked before, we've got A's and we've got B's. I'll tell you this, for the most part, B dimensions are usually for male parts. This is your, you've got your ball hooked up there. Let's see if I have something handy here. Here's this ball. Picture that sitting, a little out of scale, but that's how you would be measuring it, just like that. This sits over that, your mic over here. Let's take it a little more, okay? So that shows it that there's your ball molded to a plate. You could also put a magnet here and just drop a ball bearing in there, whatever, mic over it. This is actually better. So this actually works. So this is usually the B dimension is for male parts, and I'm going to do a female and get the A once for you, so you kind of see how this opposite works. But the biggest thing you needed to learn here, we got the same answers last week after I did my correction, and what you learned here was how to. This is the secret. Okay, and again, from here to here is 90. This is 10. So from here to here is 80. You split that in half. So now you know this angle is 40. You know the opposite is half the ball, 0.250. Then now you need to define in your trig book a formula to find for the side adjacent when you know the opposite. And again, what I did was adjacent and found something that needs the opposite. Opposite times cotangent equals the adjacent. And that's just what we did. Opposite times the cotangent of 40 degrees. And everything added up. So you can watch this as many times as you want. Send me your questions. Really sorry about the first mistake. And you can see my mistake. When I calculate them by hand, I have to add that other half of the ball in because we only solved for this. The chart that we're using already gives you that. That's why it's a chart. Okay, got it. So, hope that wasn't too confusing. And I'll tell you what, I'm going to pause this, do another quick sketch, and show you how to do solve for the A dimension. Now in this lesson, what we're going to do is learn how to solve for the A dimension. And as I just finished up telling you that the B dimension is usually for males, this is more for a female shape. Not always, but I think you see this is a female pocket that's been cut straight wall on one side, 10 degrees on the other. All right, this is going to be a lot to throw at you here, but it's not that hard, but I want to show you a few things. Remember when we did the one for the male, which I would call the male, the B dimension, I told you had to know the thickness of this block. Because if you don't know the thickness of this block, if it's not 1 inch thick, like we said it was, if it's 998, that's going to shrink the ball dimension 2/1000ths, okay? So you need to know your thickness to get your drop and your angle correct, okay? This dimension will change. The drop in the angle won't, but this dimension will go down or up if this is thicker or thinner. The caveat on this particular problem is that you need to make sure your pocket is 750 deep for this to work. If it's 749, then your drop in your angle is not going to change. So what you'll see this all transpire right here. So what we've got is a design here, and it's a block that's 3 inches wide. You need to know how wide your block is because we're going to be miking over that. Okay. Now, if the designer is really holding this dimension here and he doesn't have a big tolerance on this, I guess in all reality, this you really don't need to know that because they didn't call it out from center. It's just from this edge, and that's one of the things I've had to learn in the machining world. When they call it from this edge, and this is a plus or minus 10, they don't care. They're calling it here. So let's take a deep breath here. The designer is calling it, he wants an 875 dimension to that 10-degree angle. All right, so the first curveball was, make sure you're at 750 because this is going to change a little bit if it's 748 or 752 because your ball is either riding up the angle or down. It makes it either wider across your mics or narrower, okay? So the dimension grows or shrinks depending on if this isn't quite 750. Now, if it's 749, it's not going to change much, right? But what you need to do is first you have to figure out, well, if it's 875 to here, we got to get to here first so we can figure from there to there. We need to know from here to here. All right, so here's how it's going to work here, and it's going to come very clear to you if you just watch this. All right, first thing we're going to do, and that's why I did it this way, as I called it out at the top instead of the theoretical sharp at the bottom, is to get used to figuring your drop at an angle. So 750, 10 degrees. Remember, let's go with it. A drop in an angle formula, very simple. 10 degrees tangent times 0.750. 1322 plus 875 plus 0.875. 1.0072. So now we know a dimension to here. And it is 1.0072. Now, just like we did in the last video, or the part 1 of this video, we're going to split this angle again. And we're looking for the triangle. This is the triangle right here. So what do we know? Well, let's see, what do we know? We know this side here is a 1-inch ball. Now, quickly, what you're trying to do too when you're picking out, you saw I have a large selection of different rolls and balls. Theoretically, if you can, you like to get your ball about halfway up the angle. So try to use the biggest one you can, if you can, to get halfway up the angle. That way if your angle's, thou off here, thou off there, you're hitting it in the middle. It's good practice. You can't always do it. I mean, if your pocket's 10 inches deep, you're not going to use a 5-inch, or 10-inch wide ball. But so I threw a 1-inch ball in there. So I know from here to here, that's the radius. This is 0.500. Okay? So let's do what I taught you to do. Let's draw the triangle. We know this side is 0.500. That's the radius. Now, this is just the opposite of the last one. If we were to go from this surface to a straight line here, let me draw one for visual aid. From here to here is 90, right? 10 degrees added to it. So from there to there is 100 degrees, and you're just going to split it, as we did in the last one. So this angle here now becomes 50 degrees. I hope you follow that. 90 plus the 10 is 100, and you just dissect it, and it's now 50. That's why I always have you draw the triangle out separately down here. So what we're trying to solve for is here. All right? So, back to our trig book. We know what? We know, in this case, we know the opposite because the angles are touching here. So it's going to be the opposite. And we're trying to solve for the adjacent. Opposite times, I'm sorry, that's not right. We're going to look at the formulas here, right? So, we know the adjacent, let's see, I'm sorry. we know the opposite, and we want to solve for the adjacent. Same formula as last time. Side adjacent, opposite times cotangent. So opposite times cotangent. So let's just take 50. Tangent, 1 over x. Inverse it to cotangent, times 0.500, 419.5. So now, if we know it's 1.0072 to there, then we're going to add, so let's do the math right here. Let's see, make sure here. 1.0072 plus 0.4195 plus what? The other half of the ball. So we can mic over this, okay? Plus 0.500. It's a 1-inch ball. So $1.0072 plus 0.4195 plus 0.5 equals 1.9267. What I'm more curious about is how did if my ball dimension came out right, and I'm going to use the chart here, and I love doing this live. Hope I just didn't waste 5 minutes of my time here recording. I'm going to take the 0.4995, which we calculated, plus 500. I want to see if it matches the chart, that's all. 0.9195. So if we take our handy dandy chart here, all right, and we're going to use 10 degrees again. We're going to go for the A dimension with a 1-inch ball. So 1-inch ball, A dimension for 10 degrees. 0.9196. What did I have? 0.9195. I'm a tenth off. Oh my God. So there you go. So I just showed you how to match the chart for the A dimension, and I totally did that live. And I could do this again and find out what I rounded off, or I'm at 1/10 off. But I'm totally matched that number with the chart, just doing this live with the calculations. Okay? So watch it as many times as you want. Email me your questions. You just got a lot of information tonight. But this is for the A dimension. The first video, part of this video, is for the B dimension. A couple things, just remember, when you're doing the A dimension, you got to know the depth here. And when you're doing the B dimension, you really got to know the thickness of your part, exactly what it is, because it affects, when you subtract the drop in the angle, you know, 10 degrees from here to here, that's your point you're starting everything from. So you got to know the thickness of your block on this one. On the female version, you got to know the depth of your pocket. So you can have fun with this and play with it and see what that dimension would have come out. X equals, I forgot to put that on there, let's be precise here, 1.9267. All right, guys, Bill Kerner, the Tool and Die Guy, and we got more to go here, but you guys now know the basics of calculating ball dimensions, and I'm going to show you in the next videos how to tilt parts up at an angle and touch off and move over. But now you're starting to see this come together, A and B's. And a little tip, like I said, you try to get that angle halfway up the ball, halfway up the wall if you can. That's why I have this whole different set of balls. And like I said, I've got this is a 1-inch. I go up to 2 inches at work because I used to cut some really deep pockets when I was a mold maker. So hope you enjoyed it, and we'll see you on, gee whiz, what are we on, part 11.